Okay, so today we are going to finish just some pieces of alkene naming that we weren't able to get to in class. And that starts with just filling in some of these um, numbers from the lecture notes on page 2 of chapter 10. Um, and at the beginning of it, I say that alkene naming is similar to alcohol naming, and that's because we name to give the alkene the lowest possible number. So we used to have these different rules for like getting the lowest alphabetical thing first, or a variety of things. But if a molecule if it has an alkene and a bromide, or an alkene and an isopropyl group, or whatever, the alkene always has to get the lowest possible number. And another thing that's similar to alcohol naming is that the alkene always is included in the parent chain. So even if there's a longer chain of carbons that don't include the alkene, we take the shorter chain that does include the alkene. Also, we indicate the alkene position not as a substituent, but as part of the parent chain. But as I guess it's part of the suffix, but as the suffix. So I think when we went back to prefix, parent, suffix, the suffix had ane initially for alkanes only. Last chapter we added ol to that if it's an alcohol. Now it's going to change a little bit. The an for alkane, for alkenes, is going to be switched to en. So instead of butane, it would be butene, or instead of propane, it would be propene. And the last important thing to clarify is there's kind of a hierarchy of these first couple of rules. So alkene always is included in the parent chain, and name to give the alkene the lowest possible number. But if a molecule has both an alcohol and an alkene, the alcohol gets priority. So what does that mean? That means the alcohol gets lowest number. And we'll see an example of that down here. Okay, so here are two of the examples, and we need to first figure out what the parent chain is. And if we look at our rules, we name to give the alkene the lowest possible number. So on this example, if we start numbering right here, then the alkene would have position 1. So 1, 2, 3, 4, 5, 6, 7. That's the longest chain that includes the alkene. If we went from here, 1, 2, 3, 4, 5, 6, 7, 8, we could have a longer chain, but that chain doesn't include the alkene, so that's why we go with this chain. So what about our substituents? We have a bromo substituent and a 1, 2, 3 carbon substituent. That's a propyl. So those are our two substituents. We now need to figure out the stereochemistry. Around this stereocenter, because of the double bond, this is going to get priority 1. Then this is going to get priority 2. And this is priority 3. So if we go from there to there to there, we're going clockwise, so this is going to be R. And at this position, bromo gets priority 1, this gets priority 2, this gets priority 3. Here we are counterclockwise, so that is an S. So we have our substituents, we have the R and the S. So this is going to be 3R, 6S, and then we want to alphabetize our substituents. So bromo comes first. So 6-bromo, 3-propyl. And now comes our parent. So we have 7 carbons long. That would be hept. And then, I have to sneeze. Sneeze went away. That was weird. I was going to sneeze, but then I didn't. So now we have to go to the parent chain, 7 carbons long, that's hept. And then we have to specify, so hept. We have to specify where the alkene is. The alkene is in the 1 position, so hept, 1-ene. So technically, the alkene is between the 1 and 2 position, but we actually just say the first of the 2 positions that it's on, and then the person reading it would know that it's between positions 1 and 2. So this one would be 3R, 6S, 6-bromo, 3-propyl, hept, 1-ene. So that's that example. Now we have a second example, and this one gets a little bit complicated with that last rule. So if a molecule has both an alcohol and an alkene, the alcohol gets priority, gets the first priority. So yeah, let's change that here. So it gets first priority. So the alcohol gets the lowest number. So if we numbered from right to left, the alcohol would be 1, 2, 3, 4, 5, 6, position 6. But we want the alcohol to have the lowest possible number, so we're going to number right to left. So 1, 2, 3, 4, 5, 6, 7. So it's again going to be a hept. We have alkene at position 5, alcohol at position 2. So what about stereochemistry? We have 2 stereochemistry elements in this molecule. The first one is R or S, so let's look at that. So this O gets the first priority, then this group, then this group. So 1, 2, 3. That's counterclockwise, so this is S. What's our other stereochemistry element? Our other stereochemistry element is the alkene. Alkenes can either be cis or trans. This is trans. So that's our other stereochemistry element. So this molecule is going to be S, trans, and then hept. And now we have to tell the reader where the alkene is and where the alcohol is. So it's hept, 5-ene, 2-all. So the ene indicates that the alkene is between positions 5 and 6. The 2-all indicates that we have an alcohol and it's on the 2 position. So that is how we name these. I'm going to make another real quick video on naming cyclic alkenes next. So stay tuned for that.